we'll show you how we can machine this shape as a pocket using the area clear dialog box. So we're in the PartMaster CAD system at the moment. So this could have been where we've created the geometry ourselves, or we've imported a DXF file. But for either of those situations, the things that we do next are the same in both cases. So what we need to do is to create a datum position for machining, and to create a contour, which is a series of linked line and arc segments similar to a polyline that can be followed by the machining software. So from the main operations toolbar, we choose the CNC icon, and as you can see in this example, the datum position is down in the bottom left hand corner. Now supposing we want to move the datum, from the vertical toolbar on the left we choose set NC datum, and the system switches into near snap mode, so it will snap on to the nearest thing to the cursor. In this case it's snapping onto the center of the arc on the right hand side, which is where we want 0, 0 to be. Okay, so that moves the datum from machining to there. Now we stay in CNC mode and we want to create an NC contour. So we choose that icon. As we move the cursor over the geometry, you see how it's picking up the geometry, and depending on the position of my cursor will depend on which element is the starting point for the contour. Because in this instance I want to start machining at 0, 0, then it makes sense to have the start point of the contour close to that rather than somewhere over here. Okay, so we'll choose this line here first. So the contour and profile dialog box is displayed. I've set my line thickness to 1mm so that it's more visible for you. It automatically creates a layer which it places the contour on. Again, this is so that you can switch layers on and off, and this is so it's easier to see. In general, we can leave these options as they are. In this case the shape is closed, so the start point is going to be the same as the end point. The NC data, this is the name of the contour, and it's going to be called Con0. The Z surface, or the top of the job, is 0, and the depth of the contour is whatever you want it to be. This shape is a contour which is used for milling, a profile is used for turning. So we click OK, and it informs me that that contour has been created, and it draws it in a nice thick red line so that's easier for us to see. The actual thickness of the line won't have any effect on the sizes when we come to machining. So we can now take that through into the machining software. So first of all we save this drawing away, and I'll call it Voice 2, and now we link through to the milling software. Okay, so the first thing we need to look at is our tool change position. So we've got a tool change position of XY0 and a Z safety position of 50mm. So the tool change X and Y position can be 0. You don't want the Z tool change or the Z safety position to be 0, because then the first thing it will do is it will rapid to that position as the first line of your G-code. So make sure that that is at a sensible position. The clearance plane is above any clamps and fixturing where it's safe to rapid in X and Y, and the feed change plane is a position where, as the tool is moving down in Z, it will change from rapid into feed rate. Now I have it set so that the tools that I've previously defined have been automatically reloaded when I start a new job. If you want to take advantage of that feature, you go to View, Preferences, and under Options check the boxes Automatically Save the Tool File and Automatically Reload the Tool File. That means that as you start creating jobs and you're adding tools to the tool file, it is automatically saved and then loaded for you when you start each new job. If you haven't got tools defined, then you need to define them, and you use the define tool dialog box here. So in this case we'll set an end mill, set the size to be 12.7, and we'll set a description, and we'll call this a rough and finish tool, for example. What you can also do is you can set a cut depth, so this will be the maximum that you want this tool to cut at any time. When you change this value here, you'll notice that the line here changes, so this in effect is the flute length. Now you can use that to control the number of passes that the go round and area clearance dialog box takes when it's plunging down in Z. So you can either set it here, but I'll show you a different method as we progress. So that's set up a tool. Now we need to select that tool for use. So we can choose from the list, but if there's only one, then it'll just be displayed here. The radius and length offset registers are not normally required these days. These is for very old controllers where you had different memory registers where the radius and length information was stored. Spindle speed, set the spindle speed here. The direction will pretty much always be clockwise. And you have two feed rates. You have the principal feed rate, in this case that's in X and Y, and that can be displayed as either feed per minute or feed per rev. And then you have a Z-axis feed rate. Again, this can be described as feed per minute or feed per rev. If you have coolant control and want to switch it on, then you check the box here. So we've now got a select tool in the program operations window, so we can now do an area clear operation. So this is advanced pocketing. So the first thing it needs to know is the name of the outside contour. Well, there is only one contour here, so it picks it automatically. If we had multiple contours, we can choose them from the pull down list, or if we don't know the names, we can choose with the cursor just by indicating the contour. The Z-planes are what has previously been set, but if you want to override it and set different values, you can do here. We can also set up a finishing allowance in X and Y and in Z, which I'll come on to in a moment. We're not using any islands, so we can ignore that tab. If we want the tool to plunge from a known position, this could be where you have a pre-machined hole or some other feature where you can sink down. If you don't have center cutting tools, then this is the option that we'd use. So you choose to use the from point, and then you give it the X and Y location. Again, if you don't know the exact coordinates, you can choose with your cursor. The ramping options will give you the opportunity to ramp down in a single Z motion, or at an angle, or at a zigzag. And if you choose angle, then you set the angle here. Under the Options tab, the swathe, which is the tool envelope, is set to the maximum that you would ever want to use, and in most cases it's better to set that to 50% of the tool diameter. Contour machining will follow the shape of the outside contour and get progressively smaller if it's machining from the outside, or if you choose to machine out from the center, it will get progressively larger towards the outside contour. The unidirectional and bidirectional options will give you straight line machining, and you can either climb or conventional mill, and in most cases you want to climb mill. So as far as the options are concerned, the one which I will check is machine out from center. So as we said earlier, when we define the tool, we can set a maximum cut depth. That could be the maximum that you ever want that tool to cut, but that can be modified for each individual operation. So in this case, under the area clearance tab, dialog, we've got a Z-axis tab. So if I choose that, then I can override the tool's current cut depth setting, which was set at 40 millimeters, which is the flute length, but in this case I only want to cut 5 millimeters deep. So we click OK. and that produces the toolpath for there. Along the top of the screen here we've got the tool display and the screen display. So if we want to see the tool center line, we click that and then run the job. So the tool will start at 0 and move progressively outwards. If we animate the tool, that's the tool moving down to its first Z position, and it's machining out from the center. Now, it depends on your display. You can speed this up or slow down the actual display using the command here on the right hand side. So when it gets to the end of the first pass, it pulls up, rapids across in X and Y, and then feeds down again in Z. If I stop the display, go into centerline mode, you can see how it's taking a number of passes, each one set at the Z-axis depth here. So to modify that toolpath slightly and to make it a bit more usable, if we go to the Options tab here, one of the things we've got is Traverse at the clearance plane. So what that will do is it will track the tool to the clearance plane, in our case 50mm, above Z0 when it goes from one position to the next. So if I uncheck that box, it'll go back to the feed change plane, which is only 3mm above the current depth. So if I look in the front view now, we can see that as each cut finishes, the tool retracts 3mm, then goes across and then descends down to the next depth, machines all the way around, retracts, cuts across, and so on and so on. So that will reduce the amount of time the tool is taking rapiding between the end of one pass and the beginning of the next. So in that way we've produced the area clearance starting from a known position, and we've set a number of Z passes. The final thing we might want to do is to set up finishing allowances. So if I double click on area clear, under the main heading here I've got a finishing box, so I can add on a 0.5 in X and Y and 0.5 in Z, and by checking the box create finishing passes, it will use the same tool to machine those finishing allowances. If I uncheck that, then I would, and wanted to use a separate tool, I would need to select that tool and do another area clearance operation, but only cut to the complete depth. But if I'm using the same tool, then I can create the finishing passes, but when I'm doing this I don't want it to use the cut depth setting, which was 5mm, which I used originally, to rough this out, so that it will machine right down to the bottom. So if we now rerun that, we have the passes. Look at the front view. Okay, so we have 1, 2, 3, 4 passes. This is leaving 0.5mm in the Z plane and then producing a final cut down to remove that 0.5mm. If we look in the plan view, we can see the tool diameter, and we can see there are 2 diameters at each change of direction point, showing the roughing and the finishing tool paths. So when we're looking at the display, it's always useful to be able to see the different views so that we can check exactly what the tool is doing. If we want to see all 4 windows on the screen at the same time, we can do. Click into one window and it runs the toolpath there, and we can click into each window and run the toolpath there. We did have it where it ran the toolpath in all 4 windows at the same time, but it was so confusing that you couldn't see what was going on, so we split it so that you choose which window you want the tool to be working in. It's much more visible. If that's what we want it to do on there, then we can save that file away, and then we can post-process and run the machine tool simulator. We can do that in either order. If we want to run the simulator, we just choose 3D simulator from here. The machine we're going to use will be a standard vertical mill. When we choose the simulator or post-process, it will always recalculate the data, so if we have made any changes to it, then those will be reflected in the output. So when it's created the simulator data, it calls up the simulator, and we can accept all the defaults here and just click the simulate button. So when we're simulating, we can view either the complete machine tool, or we can view just the workpiece and the tool. So when you load the simulator for the first time, it takes a second or so to just load all its configurations. So this is showing the complete machine tool, and if I use the mouse, I can zoom in and out, use the right hand mouse key to pan, use the left one to rotate, the center mouse wheel to zoom in and out. If we want to change our view, then we can use these full focus boxes here. We've currently got machine focus, or we can go to workpiece focus, so we see just the workpiece and the tool. We have simple video controls up here, so if I choose run, and then I can adjust the speed of simulation with this slider bar here. All of the settings and colours within the simulator can be set. Okay, so that's that. If we have any collisions, they would be in the report section here. The cutting simulation, we can change the accuracy, we can set the analysis, and we can set all the colours. If we want to mark the parts and then remove one part from the model, we can do, or we can choose to see different tool numbers, so that for different tools they're shown in different colours. If need be as well, we can actually measure points from the model here, so we can get an idea of whether we are cutting correctly or not. So when we finish with the simulator, we just click the close button here. We can exit from the simulator and we're back to the PartMaster main screen, and then we can post-process for whichever machine tool or controller combination we have. When we post-process, then the window at the bottom opens and shows us the G-code file, which is then good to be sent to the controller. If we have RS-232 comms on the system and cables attached to the machine, then we can send the program directly using the Send NC Program To button here. So that just uses our standard DCOM software to send and receive programs to and from your machine tool. Okay, that's about it. We will show you